Generally, we give 5 minutes so that if someone want to join, they can join. Okay.
Okay, maybe we can wait for another 5 minutes.
No, not required. Not required. Why? Because notes also recording will be there. So if someone generally, some people after joining, what they do is some people, they think we can listen the video and all. So no worries. Okay, we can start after 5 minutes. Okay. Yeah, most of the people, yeah, they would like to go video after the session. Okay. So that should not be a problem. And you will be given access to all the videos, maybe. Okay, after a few days. Okay. For 1 year, you will be given, so you can go through the videos whenever you want.
Okay, Krishna.
Okay. So yeah, till yesterday, we have covered about database basics, right? So about primary key, foreign key, and database objects like tables, views, and what is a table, and columns, data types, and the relationships, and those things. And of course, the data modeling means the way how we should decide what is the primary key, what is the foreign key, and how the relationship between them. So all those things will be decided as part of the database design. Okay, and of course, users and creating users, granting access, and all that stuff also will be there. Okay, once we know about database is basically maybe a data up to a few gigabytes to hundreds of gigabytes, or even up to 1 terabyte. A database can handle. Generally, databases are for OLTP systems like MySQL, DB2, Postgres, RDS, those things. They are at the OLTP side, means where the transactions are happening. So they will be taken care. Okay, but as the time increases, the data is increasing. So people want to store the data, and they want to use the data for analytical purpose, means for reporting purpose. So that's where there is a need for data warehousing. So today till yesterday we have discussed about databases. So today we will be starting the data warehouse. Okay, yeah, data warehouse. So where from the data warehouse came? The data warehouse came from the databases only. So databases has some limitation, means up to certain extent of data only it can accommodate, and after that it cannot give the expected performance. Same thing, like I said, if you are using 120cc bike, and if you are using, if you are like some 3 people or even 2 people, each 100 kg weight, then even you give accelerator, it will not go more than such speed. More than certain speed. So if you want to have high speed, you should have high cc bike. Okay, so definitely, even with high weightage or even with high load in the system, if you want more speed, then the databases are not sufficient. So there is a need for data warehouses. So, and in data warehouse, the main purpose is that we want to store the history. Okay, we want to store the history and make the reports out of it. And why we should generate reports? Because we want to analyze it to make the business better in the future. Because based on the history only, we can predict the future. Okay, cool. So, for example, if you see the stock market, if anyone even just want to start, okay, even trading or that thing, first if you want to buy any particular stock, we generally see the history of the stock, like how it is performing. Okay, like how it's performing last 1 year, or how it's performing last 3 years, or how it's performing from the beginning of its stock after introducing in a BSE or NSE or wherever it is. So that means based on seeing the history, we can predict, okay, if it is definitely performing last 3 years and last 5 years and last 10 years. So that means we can make sure that yes, it is performing stock. We can buy it and we can invent it like that. So based on seeing the history of the particular stock, we can predict. Similarly, seeing the performance of a particular, for example, you take supermarket. Okay, based on, they also will maintain the history of course, they see even the store-wise performance across the cities, across the states, and all, so that they can know which store is performing better. So, if, for example, let's say the total sales, okay, or the total sales of a particular store is not well, then they can identify like what is the wrong with it. Maybe customers are not there, or the customers are looking for some products, but products are not there, so that they can keep what customers are requesting or what customer needs in that store, and they can keep the stock of it. Like I said, like, okay, store is maintaining two brands of rice, okay, and one brand of rice is there in the stock from last 1 year, okay, not even single packet are going, but other stock, other brand is going, okay, they always need to order that stock. Then in that case, always better to have more stock of the rice brand that is going mostly, rather than maintaining the other brand which is not at all going. So like that, it helps the companies to come up with some decision making if they maintain the history, and that's where this data warehouse came into picture. Okay, so general again, what is a warehouse? It's the place where huge volumes of data is stored. Okay, it's the place where huge volumes of data is stored. Similarly, if you go to, for example, a shoe shop, or I mean any shop, there you select a particular dress or shoe or slippers or whatever it may be. They will say that, sir, item is there in the godown. Or even you go to, you see, furniture shops. If you order any item, they will say that, sir, we will deliver the goods from the godown. So actually, godown is the place where the huge volume, I mean huge stock is stored. It's a store. Similarly, since it's a data, so it is also godown and warehouse, both are interchangeably used. So since it's data, so it is called data warehouse. Okay, so because in data warehouse we maintain even 10 years, 20 years, 30 years, even 40 years data will be maintained. For example, you take LIC or life insurance, any life insurance. And life insurance generally not just 5 years or 10 years, it's even 30 years minimum. Each policy will be 25, 30 years. And that means we have to, or they have to maintain the history. Otherwise, how do they know which customers have been paying and who are not paying? And what is the maturity date and what is the maturity amount and all. So the policies are very, 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 very long, like 30 years, 40 years and all. So they have to maintain the history. So that's where the data warehouse. And based on the like how the customers are buying the policies, every time some new policies are coming up. They say that this is a feature and that is a feature and all that stuff. So basically, that they will introduce some change so that whoever the buyers who are not purchasing policies, I mean they can get inclined, or they can get show some interest and take some new policies. So like that, somehow they want to attract the customers and get their business done. Okay, so that is even our companies, okay, who are customers we are working, they also trying to come up with some new decisions, okay, so that and increase their business better. So for that, the whole thing is that it's data warehouse. Okay, so they maintain the data and they analyze the current business and see where they are doing good and where they are not doing good, and they will see why they are not doing good in particular area or in particular region or in particular state or city, and they come up with a plan which can overcome the existing ones, and that is the way they will improve the business. Okay, cool. Okay, so now we have, I mean, till now we have seen databases and data warehouses. Okay, then in databases we know the data is stored in terms of tables, primary keys, foreign keys, and all these things. Okay, that's fine. Then what about in data warehouse? In data warehouse also data is stored in terms of like tables. Answer is yes, it is also in terms of tables, but here it's not like primary key, foreign key, and all that stuff. Okay, here the tables are called fact table and dimension table. Okay, so here the tables are called fact table and dimension table. In data warehouse, yeah, table is same, like rows and columns will be there. But since we are talking about data warehouse, just terminology changes. Okay, fact tables, dimension tables, and all. Okay, so what is a fact table and what is a dimension table? that we need to know. So, and how they decide whether it's a fact table or dimension table based on the nature of the data. Okay, so in fact table means all the numerical values or measures will be there. Numerical values means like numbers, number data. Okay, so for example, sales, quantity, sale price, total sales. Okay, so items sold, all are numbers. So fact table means a table which holds measures or numerical values. That is called fact table. Okay, so this is the database or data like data warehouse terminology. Okay, so I will tell you also the examples. I mean later after this. Just now the terms I'm introducing. Fact table means a table which holds numerical values or measures. Okay, then dimension table. Dimension table means the table which holds the description about the fact data, okay, or which describes the fact data. That means, for example, fact data will have quantity and total sales. Okay, so a number of items sold. I mean that is what quantity and total sales. Okay, then what are those items or which items are sold? So dimension table will talk about product product description, like okay, product color, brand, manufacturer name, okay, like item sold, like date. So these items will be held by the dimension table. So this kind of descriptive data will not be there in the fact table, because fact table is basically it holds only measures or numerical values. Okay, and all the things that describes the fact table will be held by the dimension tables. And of course, there will be some relationship between fact table and dimension table that I will tell you now. Right now, we should understand how the data is stored in the data warehouse. Of course, in terms of tables only, whether it's database or data warehouse, in terms of tables only. But here, the tables are called fact and dimension table. I mean, generally, they will ask you these direct questions: what is fact, or what is fact data, or what is fact table, or what is dimension table. So the people expect that you know these terms, okay, because we are into data warehousing. So, okay, cool. So, fact data means the numerical values or measures is called fact data. A fact table means a table which holds numerical values or measures. Plus, online statement. And dimension data. Dimension data means which describes the fact data is called dimension data. Okay, cool. And then how that means what? The dimension, whatever attributes means columns of the dimension table will actually describes the fact data. For example, as I already said, fact table has for example, number of quantity and total sales. Then which items quantity it is, what is the product name, what is the brand name, or what is the manufacturer name, so what is the batch number. So all these things will be described by the dimension table. Okay, so then if you want to understand a particular brand name, what is the total sales, then you have to join this dimension table as well as the fact table. Why? Because fact table has the quantity like total sales, and the dimension table has the brand name. So these two tables, if you join, then you will know brand name wise total sales. So like that, brand name wise total quantity, because quantity is there in the fact table and brand name is in the dimension table. So at that time you have to join with the dimension table with fact table. So okay, cool. Okay, now we know like what is fact table and what is dimension table. So then how to establish relationship between them. So the relationship between fact table and dimension tables are called star schema and snowflake schema. Okay. Star schema and snowflake schema. So that means in data warehousing, how the tables are related is known by like what is their design. In any design, the tables like are only two types, like fact tables and dimension tables. And what type of design they are using or what type of schema design. They call it as schema or schema design. Means most of not only most, all of these customers will be using either of these two, either star schema or Snowflake schema. Okay, so what is star schema means? A fact table surrounded by denormalized dimension tables is called star schema. I will tell you everything. Okay, just only listen. At the end of the session, you can ask questions. Star schema means a fact table surrounded by denormalized dimension tables is called star schema. Okay, cool. Okay, what does it mean by denormalized dimension tables? So actually, I mean, we must have studied it while studying databases and all. Normalization means splitting the larger table into smaller tables by having common columns. Anyway, if you want to divide a big table into small table or a table with more number of columns into multiple tables having less number of columns, we should have a common column. Then only we can join them and get all the data. So star schema is to fact table will be there and then dimension table will be there. And the dimension table, just one dimension table for each dimension. Okay, for example, there are different dimensions like region, one dimension. Region means it will have region, country, state, city, like that. And time dimension will be there. Time means date, week, month, quarter, year, like that. And yeah, state, region dimension, time dimension. Of course, for every product there will be product dimension, or for every customer, I mean, remaining whatever tables we are using on their particular descriptive data. Product means product name, product manufacturer, product brand, those things. Customer means customer name, like customer email address. So yeah, those related details, every descriptive data about the customer. So okay, then star schema means fact table will be there. Fact table is surrounded by dimension table is called star schema. And generally, star schema, since all the dimension that is present in single table, so there is data redundancy will be there. I'll tell you what does it mean by data redundancy. Data redundancy means, for example, I have customer, customer name, customer region, okay, so customer city. Okay, so now you see this particular customer table has 100 million records. Okay, how many records? 100 million records. See here, actually here, this is a, of course, all customer descriptive data only. Okay, customer, okay, customer name, customer region, customer city. But here you see there are two things. One is customer related details and the other one is his location related details, region and city. But this we consider as a single dimension table. And usually, let's say customer ID, okay, some 1001, 1002. Anyway, it's like 1002 and like that. Okay, some how many, like 100 million. Okay, 100 million records are there, and of course names will be there. Okay, some XYZ. So some names will be there, and you see region. You see all the day 100 million records. Regions are hardly 5 or 6, like SF specific. Okay, I mean right, that regions, APAC, Asia Pacific, and some US related region. So, and for example, only there are only some 3 to 5 regions are there. Okay. So, for example, you see the Singapore, India, these all comes under Asia Pacific, and some US countries comes under into EMEA region, and some Europe countries comes under into some region. So, only these regions, only these APAC, EMEA, and okay, some EU. EU means some Europe countries related. So all these 100 million records only, these particular values only will repeat. Okay. So although you have some 100 million records or 1000 million records or how many records, all the things. So it doesn't matter it's 100 million or 200 million. So all the records will have only these values only. And cities are also okay. Whatever cities are there, I mean, for example, each region has some 100 cities. Then like 5 regions. Okay, 5 into 100, 500 cities. So only those cities only will repeat here. Okay. But total number of records, how many we have? 100 million records. That means there is a duplicate. Okay, this is called redundancy. Okay, redundancy means data. You see that data there is no limit, because we can have 100 million, 200 million, or as the date increases or as the time increases, it can even become 1,000 million records also as they. But they all belong to same region. I mean, they will be one of these 5 regions or 3 regions only, and they will belong to one of the cities. So that means the particular data redundancy will increase. So what they do is they divide this into customer table and region. Okay, customer dimension, and the other one is region dimension. In region dimension, they have region, and of course COUNTRY, country, city or state and city. Okay, of course in customer they can have customer ID, customer name. Okay, so I mean customer email address, so whatever they want. Okay, but you see here in region, now this region will have only, let's say we have only 3 regions. So that's all. The region will have only these 3 values here in this table. And of course, country will have, let's say country, okay, let's say each country has some 100, I mean, each region has some 100 countries, not 100 countries. Generally, region can have up to 50 or 60 countries. So then, so the country, APAC region countries will, so for example, Asia Pacific, right? So, okay, India, Singapore. So all the countries will come here. Okay, and again EMEA region countries will come here. That means here we are have duplicate or redundancy of hundreds and millions of records, same values. But here we hardly, okay, how for example APAC will repeat here, but how many times it will repeat here? It will repeat only how many countries are there, that many values only will repeat here. Okay, for example, it has some 50 countries, then it will repeat only 50 times. So like that, that means we are greatly reducing the redundancy. That is my point here. When do we divide a big table into small table? Because generally if the same data is present in the single table, because each field has to have the data, so it has to be repeated. Okay, if the table has like 100 millions of records, 200 millions of records, like that. But you know, it unnecessarily occupies the storage. So to reduce the storage, we can divide that into smaller tables so that the small table will have only less number of records, and thus it will reduce the redundancy. I mean, that is what it is. So what does it mean when denormalization means? Dividing the bigger table into smaller tables, okay, so that data redundancy will be less. Data redundancy means duplication of the data. You see, if you don't have if you don't divide, then the same table which has 100 millions of records has to repeat all the regions into 100 million or 200 million times. So which is not a good case. So that's the reason. If people are using star schema, then the same they will be using is, if people are using star schema, they will be using this particular dimension table. You see, okay, this particular table. If they're using Snowflake schema, they'll be using two tables. Okay, so one is customer related table and other one is region related. Okay, like that. So here what is the difference? In one, they are only using one dimension table, okay, where all your data is present in single table. Here they split the table, or they divided, or they normalized. The right term is they normalized the table to have separate data separately for each region. So okay, then
So
what the star
Krishna,
schema means? Yeah.
Krishna, question, Krishna.
Yes.
Yeah, first one, like, column number A to B, right? Column number A to C in the Excel.
Yeah.
Okay. This one
Yeah.
is, you are saying denormalization, this table. The first one, like, CX, C name,
Yeah.
CX region.
Yeah. This one. This one.
Yeah.
Yeah. Yeah. Yeah. Yeah. Hello. Yes, I'm
Yeah,
saying,
Krishna.
yeah. Denormalize means all the tables. I mean, all the columns present in single table. That's what denormalize means.
Got it. Got it.
Yeah. Yeah. Normalizing means dividing them into to have separate tables. Okay.
Yeah, that one is like, yeah, yeah, got it.
Yeah. Okay. Now, why it's called star schema? Why one is called star schema and why another one is called snowflake schema? Star schema means fact table will be there, okay, and it is surrounded by dimension tables. Okay, so one for is here it's said item. Okay, I mean it depends on, like, for example, if it is some bank or something, you see here branch, or not only branch, even for even supermarket also it works. Okay, branch, time dimension. You see time for everything, one key will be there. Okay, because these are dimension tables, so one key will be there in the dimension table. Day, day of the week, month, quarter, year. And in item, of course, item key will be there, item name, brand, type, supplier type, or manufacturer type, those things in case of item. In case of location, again location key, street, city, I mean what it may be, which describes about the location, country, and all. Okay, so in branch, again branch key, branch name, and branch type and all. Okay, so here in star schema, what happens is that dimension tables will be there and fact table will be there. All the dimension tables will have their own like keys. Every table will have key, right? Like primary key. This is their primary key. They will be used in the fact table. Otherwise, how do they join the dimension with fact? Based on the keys only. So location will be there, location key, branch will be there, branch key, item will be there, item key, time will be there, time key. Like that, even if you have other dimensions also, it will have some key, that key will be referred here. Okay, and why should we have that? That is called common column. Okay, we said, right, common columns will be there to join. Okay, and for example, we want to know what are branch wise, okay, I mean branch wise total sales. Then the sales table will be joined with branch table based on branch key. Okay, and of course dollar sold or average sales is there in the fact table, so they can get, okay, branch wise average sales or branch wise dollar sold means sum of dollar sold means total sales. Okay, let's say we want month wise branch wise total sales, month wise branch wise total sales. Then you have to divide with time dimension also. See here in time dimension you have month. Okay, so and you have to join the time dimension with fact table based on time key, and fact table again joined with branch table with based on branch key. Okay, branch key it joins with branch table, and the time key it joins with time. Okay, so from time dimension it will take the month, and from branch it will take branch, and the total sales it is there already in the fact table. So like that.
Krishna, how many the here we can see fact table, right? How many dimension table we can join with fact table? Do you have any limitation on this one?
No, there is no limitation, right? That's why if you see in our real-time projects, we will have different subject areas. Okay, subject areas means basically it talks about particular business. For example, you take banks, credit cards. I mean that is one particular area, and customers, loans. So yeah, each one will have its own, the source schema, because the tables related to credit card is separate. The tables related to loans is separate. The tables related to like accounts like saving account, current account, customers, these are different, so we don't clump together. That's why there is loans department is separate, credit card department is separate, and accounts department is separate. So actually related, if you talk about loans, yeah, there is no like limitation like how many dimensions, or we have to consider all.
No, no, no. I'm not talking
Loans.
about the dimension. Fact table, like, do you have any limitation
Okay.
on to create fact table?
No, there is no limitation. In
So
fact table
fact
also
table
there is no
to,
limit.
okay, got it.
Yeah, there is no limitation, because the fact table is going to have the keys of all the dimension tables. So that means we can join with other dimension tables also. So that means we are getting the data we want. Okay, you got it right. As
Yeah,
long as
Krishna,
we are getting, yeah, as long
got it,
as we
got
are
it.
getting the data, yeah, as long as we are getting the data that we want, then there is no need for another fact table. Okay, let's say we are not able to get the data from the existing dimension table, then we may go for another fact table. Okay, and so sometimes here again I should tell something. The fact table has keys, and these are all called measures. Okay, so what is this? Unit sold, dollar sold, average sales, and all. For example, as you said, there is a need. Okay, like we are not able to get some other for example, let's say we need to connect this star schema with some loans, okay, loans related tables. Then we can have another fact table having only with the keys. Okay, that will not have measures, only with keys. This, and it will not have measures section. Actually fact table has two sections, one is key section and other one is measures section. Key section means it will have only keys of the surrounded dimension tables, and measures means it will have only measures. So whenever the cases, sometimes we have to join with tables related to other business area like loans or credit cards. So at that time we may have another fact table with only keys. So that particular fact table is called factless fact. This is one of the question we get. Generally, these are all theoretical purpose only, but generally in the real-time scenario, I mean, it's not. So the fact table with only key section is called factless fact. Means actually it does not have any measures. Okay, measures we generally have in one particular fact table. Okay, remaining, if you want additional fact table, it will only have keys. Keys means joining columns. That's all, because we have to join with other tables, right? So that will not have any measure section. So a fact table with only key section and without any measure section is called factless fact. Why measure section is only called fact, right? Measures are only called facts. Okay, so units sold, dollars sold, average, these are only called facts. So the fact table, it does not have these facts. So that's why it is called factless fact. Okay, but yeah, generally fact table means it will have key section and measures section. You see the pink color is called measures, units sold, dollars sold, average sale. So that is called measures, and the others are called keys. So fact table, what are the two sections of fact table? Key section and measure section. Why should we have key section? Key section should be there because we have to join with other dimension tables. Yeah, and fact table which does not have measures is called factless fact because it does not have any facts. Yeah, okay, good. So what is a star schema? Star schema means a fact table surrounded by dimension tables is called star schema. And what are those dimension tables? Those dimension tables are denormalized in nature. That is very important point. Denormalized means all the data present in the dimension table only. They are not further divided. Okay, a star schema surrounded by denormalized dimension tables is called star schema. Okay, a fact table surrounded by denormalized dimension tables. Denormalized means all the dimension data present in a single table, single dimension table. That is called star schema. Okay, then what is snowflake schema? Snowflake schema means a fact table will be there. Okay, dimension table will be there, but dimension table will be further divided. Why? Like I said, to avoid redundancy. Okay, for example, you see the location is there, it can be divided into region and country and all like that. Okay, for example, you see here, again it is again further divided into specific to region, Europe, North America, and again Europe is divided into country and all. Okay, so that means a fact is dimension table, if it is further divided into smaller dimension table, that is called actually normalizing. Normalizing means a big table will be further divided to have smaller, okay, smaller tables to avoid data redundancy. Like I said, how the data get redundant? It will data get redundant because it's like this. If you put all the data in single table, so the columns which has only less values, they has to get duplicated because it has 100 million records or 200 million records or like that. So if you divide that into, then you can avoid duplication to some extent. So like that. So okay, then why? Okay, for example, okay, star schema. What is the difference between star schema and snowflake schema? Star schema means a fact table is surrounded by denormalized dimension table. If you tell that, that means he will understand that you knows it when you say denormalized specifically. Okay, and what is snowflake schema means? Is fact table surrounded by normalized dimension tables. Fact table surrounded by normalized dimension tables is called snowflake. Star schema means fact table surrounded by denormalized. You need to you see, if you are an expert, based on the terms you use, he will know that you know it. But otherwise, I mean, like we tell some definition, he clearly knows that maybe we don't have much clarity. I mean, something like that, he will know. Okay, tell me in which schema you will have more joins. In which schema you will have more joins, star schema or snowflake schema?
Snowflake.
You mean more joins means finally, you see, I will tell you. I mean, first understand the question. Although you see here in star schema, we have fact table surrounded by dimension table. Okay. In Snowflake schema, fact table will be there and dimension tables are further divided. Okay. Further divided. Okay. But to get the data, even the dimension table are further divided, we have to join them and get the data right. For example, location is divided into region and country. Let's say region and country. Okay, region will be there, region, country columns, and country will be there, country, city, state. Okay, those will be there. But
That
to
one is
get,
a
for example, location wise, yeah, saying something.
no. Whatever we are
So
going to subdivide, right? That is called like snowflake one, right? Uh, So, for example, the
yeah,
location you're dividing into two parts, right? For example, Toronto, like under like Canada, they have Toronto, Vancouver. US
yes,
is
right,
divided into states, and Europe is
yeah,
divided into the Europe countries. That is called like snowflake one, right? So,
yes, right, right.
joining is the more tables in the snowflake only will join more.
Yes, you're right. Yeah, that's what I just want to, I mean, explain so that people will get more clarity. Yeah, you're right. Okay, yeah, definitely. Yeah, that is the point I wanted you to get. So I'm just trying to explain. Yes, because in Snowflake, we are further dividing. Okay, so that's why you need more joins in Snowflake. Okay, because the dimension tables are further divided. So you need more joins. Whereas in star schema, all the data, whatever you need, it's already there in the dimension table. So you don't have to join because first of all, you're not splitting the data. So when you're not splitting, then you no need to join. Okay, but in Snowflake you're splitting means you're dividing, so you have to join to get the data. Okay, cool. So here you will have less joins in star schema, and in Snowflake schema you will have more joins. Okay, fine. Okay, then in which dimension model, these are all called dimension models, in which dimension models you will have more redundancy, star schema or Snowflake schema? Redundancy means more duplication of data will be there where.
Star schema.
In a star stream.
Yeah, cool. That's all. Why? Because in star schema, all the data present in single dimension table. So we basically end up having some redundancy, right? And especially if you have customer base is more, then you will have more redundancy. So definitely redundancy of data is there in the star schema only. Okay, even to avoid that redundancy only, people are dividing them into smaller tables to avoid that redundancy. Okay. Cool. Okay, then what is the, I mean, generally the question, even if you try in Google also, in fact, I have been in training from so many years. I already researched these things. There is a common question that's going on. What is better, star schema or Snowflake schema? And while answering that question, you should not say that star is better or Snowflake is better. Okay, both have their own pros and cons. You should tell both the pros and cons of each schema. Okay, so you see in star schema, all your data is present in the, I mean, dimension table. So just by querying the dimension table, you will get all the data. So you don't have to join also. So, but in real time, sometimes joins are complex, right? So in Snowflake schema, you will have more joins. So sometimes performance may be, okay, performance may be like little challenging because you are joining multiple tables. Okay, of course here you are avoiding data redundancy. Okay, so that means you are saving the space, storage here you are saving. Okay, in Snowflake schema, because less redundancy but more joins. Here more redundancy and less joins. Okay, so you are querying the data directly, so you can get more performance. Okay, but here there will be multiple joins, so there may be less performance. Okay, but storage here is short schema, storage is like more. But nowadays, even the customer says or the interviewer says storage we don't bother much, then it's okay, no problem, start schema. Because start schema is, since more redundancy, you may end up paying more storage. You will say that, yeah, storage would not be a problem, then start schema would be better. And especially the small enterprises and all, where they think that no, storage is also a little concern. Okay, and joins are fine, no problem. And anyway, they are small enterprises, so they hardly have not much data. Okay, so even they have data, they may be like a few hundred gigabytes or even some terabyte. So Snowflake schema, okay, joins are fine for us. Okay, storage is a little concern. Then Snowflake schema. Okay, so like that we have to see, because enterprises based on their data and the nature of their business, they will select. Okay, actually storage is not a concern, then they'll go with star schema. And storage is bit concern. Okay, but and major direction of deciding is some people voluntarily go for Snowflake schema, because in Snowflake schema we can have multiple dimensions in multiple angles. You see here in dimension table we can have region wise, state wise, even city wise. Okay, we can have different tables. And even you see, even if in date dimension also we can have, okay, the same table is divided into a different granularity, like for example day, week, month, and month, quarter, year. Okay, I means a different level, a different hierarchy. So if company is more inclined towards having data at different granularity, granularity means representing the data at the lowest level of, okay, where you want to see. So at that time you have to divide the dimension data into, I mean, whatever maximum possible lower level. So at that time, I mean, generally companies, they want to see the data at the least possible direction. Okay, so for cube reporting, cube, I mean, you must have heard cubes will be there. Okay, so they call it, yeah, this is called some type of cube or something. Okay, like cube, this is shape is called cube, right? Means they want to represent their data in multiple dimension with respect to region, product, month. Okay, so at that time they voluntarily go for Snowflake schema. Okay, Snowflake schema, although it has multiple joins and all. Okay, so that's why we should not say that this is, I mean, okay, suggested, that is not suggested, not like that. Customer would be going as per their business requirement. Okay, both have their own pros and cons. Okay, but still customers would be going like how they want to use or get benefit out of them. If, okay, although like Snowflake schema need to join multiple tables, but more uh, they want to see their data in a specific dimension or specific direction, that would be possible in Snowflake schema. So they can go further. Okay, but no problem. Even in star schema also you can get that, right? Even day wise also you can get that. But here what you will be end up joining, all the data, because here the date dimension also going to have more data. Okay, and of course, and at the same time you also will be joining with other dimension tables like items, branch, or customer. So you will be processing more data, but your storage is not a concern, but you can get that reporting anyway. Then you can go from here itself. Okay, so that's why we should, I mean, if you say that only star schema is better, you will think that you don't have, maybe you don't have like proper or idea, or you have not worked on, or you have not seen much customers, like that impression he get it. You should not say. You see any number of posts in Google, he will not say that this is better, that is better. He will say that both of them have star schema, and I mean, both of them have their own pros and cons, and customers will be using as per that, and they also suggest you to tell like that only. In fact, that is correct only. Okay, we should not say only star is better. Then what is the use of the Snowflake? Then why did they introduce? Okay, that is the reason these two are the widely used. Okay, in the real time. Okay, cool. So now you know like what is fact table and what is the dimension table and all. Okay, fact table means it will have only fact data. Fact data means a table which has measures or numerical values. And dimension table means it will have description of the fact table. Okay, that means it will have all the descriptive data which describes the values present in the fact table. Okay, cool. Then the dimension tables, this is also again very important concept. The dimensions will tend to change over the time. Okay, you see, for example, I have one product. Okay, the product even you take some, for example, some Fair and Lovely or something, okay, some beauty product. You know, earlier it was coming in a different, I mean, it is coming with different name, okay, and it's coming with different color. Now it's coming with different name. Some name changed, okay, something like advanced or some something they will change, okay, and they coming with different color, okay, some different uh, color and different brand, so like that. So that means dimensions will tend to change over time. Sometimes manufacturer will change, sometimes supplier will change, sometimes product color will change, okay, so brand will change. So that means dimensions will tend to change over time. That's why they are called slowly changing dimensions. Because in data warehousing we are dealing with some 5 years, 10 years, 15 years, 20 years, 30 years, okay, duration. So in 20, 30 years, so many things are going to happen, right? Of course, only these changes will happen, only dimensions, okay, facts does not change, because even you have same total sales, average sales, quantity sold, and those things only you will be representing or reporting, okay, but the products, brand, manufacturer, color, these things only will going to change, okay, the dimension tables. So that's why they are called slowly changing dimensions. This is very, very, very important. He will just ask, do you know what is SCD? SCD stands for slowly changing dimensions, okay. Slowly changing dimensions are of three types, majorly three types, okay, and all others are combination of these three. Okay, slowly changing dimensions are means dimensions tend to change over time. So they are categorized into three types: slowly changing dimensions, SCD type 1, SCD type 2, SCD type 3. Otherwise sometimes they'll ask what is SCD. Immediately you should know he is asking about slowly changing dimension, you should say slowly changing dimension. Okay, what are different types? That is the next question. They are mainly into three types: slowly changing dimensions type 1, type 2, and type 3. Okay, what is SCD type 1? Okay, in SCD type 1, we'll maintain only current data. For example, employee table. Okay, employee table. In your company, employee table will have, should have always current employee data. Okay, current employees or active employees who are working, that data only it will have. If you call to that HR toll-free number or HR number of your company, they will have access to only SCD type 1 tables. Means only latest data. Okay, so because that is the reason in company only these three types of data will be required. That's why we'll maintain. For example, daily we are doing batch load, right? Batch load means every day we will be running loads into the data warehousing. Yeah, we are from data warehousing background, so daily we know that some jobs are running. What do you think that they are? What do you think that those jobs are? Those jobs are actually we are loading the data from, okay, what is the POS, point of sale, means wherever the OLTP transactions are generating, like railway reservation transactions or ATM transactions, or if it's supermarket daily transactions, that data they will be captured every day at OLTP systems, and that data only we are loading at the end of the day as the batch. Okay, and where are we loading? We are loading into different tables. Those tables are only called SCD type 1, type 2, type 3 tables. SCD type 1 means the tables which are maintaining only current data. Means because in business also there are different needs of the data. For example, as I said, customer care people, they need only current data. Not only customer care, even our HR people, call center, okay, they need only current data. They don't need people, okay, I mean last 10 years who are there, they don't need. And in fact, okay, they will be given only current data because they need to answer current employee questions, okay. And that is SCD type 1. I'll talk about SCD type 3 also. In SCD type 3 means they will have also, you see, current data plus recent history. Recent history means like last 3 months data, 6 months data, like that. And this is also another type of, you know, customer care executives. They will have access up to some 3 months they will be able to see. For example, if you talk about your postpaid bill inquiry, they will be able to see maybe up to last 3 months, like what is your due, or last 3 months, like what all you have done, like any recharges you have done or you have paid and all. So, and even some of the, not some of the customer care executives, they will be having some up to some 3 months or some 3-4 months history they can see, or maybe up to 6 months, but they cannot see more than that. Okay, because that is the requirement or that is the job need. So based on what is the need, they will be, I mean, we should maintain such kind of tables, right? Yeah, definitely based on need only, company will be maintaining the tables. So then how to maintain SCD type 1 data and have SCD type 3 data and SCD type 2 data. So that is what we will be doing in our, anyway, I will be telling you the logic, okay, like how to maintain SCD type 1, SCD type 2 and SCD type 3. And among them, SCD type 2 is the most, even at the, you see, I have joined, okay, I have given in, and in each and every interview they asked about this SCD type 2. I mean that you also know, SCD type is such a important thing. In every interview that will keep coming. What is SCD type 2? How do you implement? Okay. SCD type 2 means it will maintain current data plus complete history. That is SCD type 2. Complete history you will maintain. Okay. So very important. Just for now, you remember slowly changing dimensions. Okay. Dimensions will tend to change over time. And that's why they are called slowly changing dimensions. They are mainly into 3 types: SCD type 1, SCD type 2, SCD type 3. SCD type means they will maintain current data. SCD type 2 means they will maintain current data plus full history. SCD type 3 means current data plus recent history. Okay, and I mean, since we all implemented this, but we may not be knowing like why we wrote code like that. But when I say, you will know like, oh, that is the reason we are writing logic like that, or that is the reason we are writing logic like that. You will understand when I tell about them. Okay, which we will do tomorrow. So do you have any questions?
Krishna, we are going to create all these tables into AWS Redshift, right? So whatever we are learning right now.
These are only data warehousing basics. Okay, not from here. Once after we start the Redshift, okay, yeah,
Okay.
there everything we are going to do. Yeah,
Yeah.
actually, yeah, our Redshift class will start from, yeah, Redshift architecture. Yeah, from there we are going to do everything.
So okay, got it. So so this week we are going to start Redshift, or like do you have any plan? Like can you maybe you already shared it, or maybe your people are already shared it, but I
No,
maybe
actually,
forgot.
tomorrow we will be starting architecture. Okay, tomorrow what all we will be considering is SE type 1, type 2, type 3. Okay, I mean, especially type 2, I will be telling you how it will be implemented. After that, only architecture tomorrow will start. Okay, tomorrow only we will be starting the Redshift. Okay, but if you do, I mean, these whatever I'm telling now is an additional. Okay, additional to know like what is going on in IT.
Yeah,
Okay,
that I agree
so
with you.
yeah, so actually tomorrow, second half architecture only will be started. Okay, Redshift architecture.
Very good, very good.
Hello. Hello.
Yes,
So it means
yes.
what we have been doing is particular is related to general data warehouse, irrespective of which particular data warehouse. Hello.
Sorry, Johnny. Yeah.
Yeah, I'm saying, I mean, what we have been doing so far is related to general, that's all data warehouse, irrespective of particular type.
Right.
Okay.
It is just like prerequisite
Yeah.
to the
For the,
what we are going to. Okay.
okay. Yeah.
Yeah. Because people of different background will come, right? Okay. For example, VK is from mainframe. Okay, he is completely like new to data warehouse. So
Okay.
maybe other people, yeah, just give some boost up before going to the main course.
Okay.
Yeah, it is most
Yeah.
important. It is most important thing, Krishna. Whatever you're doing, the right way, like it will other people also get the refresh. And if we know also, we maybe miss something. So thank you so much, like covering that concepts also.
Yeah, right, sir. Yeah, because we finally you should give what you actually need, although you know it or you don't know it. Because when you go to interview, basically they will be asking this. Me, because that I know. Okay, so because although you don't know it, I should give it so that you will get benefit of it.
Yeah. And Krishna, could you please share whatever you are trying to show into the that PowerPoint, right? So can we have that file or only for teaching
No, no,
purpose?
no. See, everything will be given. No worry. I mean, don't worry. Okay, the notes, including these notes. Okay, that PowerPoint. Okay, everything will be shared to you. Okay,
Okay.
so yeah, I mean tomorrow or anytime you can just drop me your email addresses. Okay, tomorrow you can drop all of you. Okay, I will be sharing the generally, in fact, I'll be sharing my email address and the phone number also. I mean, once you all confirm the payment, okay. Generally, we are asked not to share, but after the making payment, yeah, we will be sharing, and you can directly reach me on my WhatsApp and all. Okay, during any concern of any issue, even if some of your team member is facing any issue, you can directly check with me. I can help you.
Okay, definitely,
Okay.
Krishna. Definitely.
Thank you.
Definitely
Yeah.
will reach out to your company people to pay the payments, definitely. And yeah, we'll see you tomorrow.
Yeah, sure. We'll see you tomorrow then. Have a great day.
87. Thank you.
Yeah, thank you, sir.
Thank you, Krishna.
Yeah, thank you. Thanks. Take care. Bye. See you tomorrow.